morning. Welcome to 6th grade math. Welcome to 6th grade math. I am Mrs. Jack, and I teach at Gresham Middle School. Today, this series of instruction will cover area of polygons. So, let's get started. So the standard we're going to be covering in this series of lessons is 6GA1, which is Geometry Standard 1, and it is about finding the area of right triangles and other triangles, special quadrilaterals, and polygons by composing into rectangles or decomposing into triangles and other shapes. Know and apply these techniques in the context of solving real-world and mathematical problems. So moving right on into what we're going to be talking about. We are in section 1 of the At Home series, and we are going to be covering area of polygons. Within that, we're going to be talking about area of quadrilaterals, area of triangles, solving area problems, and area of polygons. So let's talk about some content vocabulary. We have polygon, and a polygon is a closed plane figure formed by 3 or more line segments that intersect only at endpoints. Then we have a quadrilateral, and it's a type of polygon that has 4 sides. It's like a parallelogram, a rhombus, a trapezoid, and then we have our trusty one here, triangle. And it is a type of polygon that has 3 sides. Now, going back down, we're going to talk about some lesson vocabulary. We have decompose. It's taking a shape apart and breaking it into other parts. And then we have compose, and that's putting the shape back together to form another kind of shape. On this slide, you're going to see that we have the area formulas listed for what each of the quadrilaterals or the polygons that we're going to be using. These are all the formulas for you, but we're going to go into that a little bit further in the next few videos. So, video 1 we're going to talk about is activity 1, area of parallelograms. So let's go ahead and watch the instructional video. Okay, for our first activity, we're going to understand the area of parallelograms. And you can kind of see the purple diagram there shows you basically what we're going to do, but I'm going to do the blue one with you that has the actual trial problem that we can work on together. So I went on ahead and I drew out your parallelogram. So the base is 14 here and 14 here. The height is 6. So you can see that 14 here is the base. And this dotted line right here is the height. It's the height of the parallelogram. And we see the height is 6 centimeters. Notice I have a dotted line through there. That indicates the height of that parallelogram. But if we took scissors, or we could even just draw it out right here, and I'm just drawing with some green marker. If I just took my green pen and I just went all the way through that figure, and I actually cut off this portion of it right here, and I wanted to lay it over here on this side, over on the other side of that figure. And I'm just going to draw it in dotted lines here so you can kind of see it. I chopped off this triangle on the end, and I made a copy and I put it right over here on the other side. When I did that, you can see that the shape that I have formed is no longer a parallelogram, but it's a rectangle. And we all know the area of a rectangle. So if we think about a parallelogram in terms of a rectangle, we understand that the area would be base times the height. And in 5th grade, you probably learned it as length times width, but for this we're going to talk about it as being the base times the height. See, we have our base down here, we have our height of our figure here. So our base is 14, our height is 6, and 14 times 6 is 84. And we don't just leave it as 84 because it tells us it's centimeters. And when we're talking about area, we're talking about everything that is inside the figure. So therefore, it would be called 84 centimeters squared. And that is how we find the area of parallelograms. Okay, so that's a parallelogram. Now let's look and see how we would find the area of a trapezoid. And so I have an example at the top and I have a practice problem right here. So let's watch the instructional video. Alright, so on this video we're going to learn how to find the area of a trapezoid. So you can see the first trapezoid that I have drawn is in purple. And you notice that I have base 1 is 17, base 2 is this line right here, and it is 39 feet. Then we have that dotted line across the middle there, which means with that little house that this represents the height. So I went on and drew your arrow here so you can remember height. Base 1, 17, height, 16, base 2, 39. Well, when we look at that, I think to myself, what am I going to be able to figure out the area of that figure with? We want to try to put everything in relationship to a rectangle or a parallelogram, okay? So the first thing I did after drawing the original trapezoid is I drew a copy of it in blue. And that's what this is right here. This is just a copy of this original trapezoid. And I even drew the little height so you could see it. Now, this represents 39 feet. So that means up here has to be 39 feet. And this right here represents the top, so we flipped it upside down. So now it's going to represent the bottom. And then this still represents the height, which is 16. So now we want to understand that this entire shape now represents a parallelogram. And the parallelogram, we know that we can solve area of a parallelogram by using the area of a rectangle, which is base times height. But we have two bases, so what do we need to do? We need to add them together. 17 plus 39. So 17 plus 39 is 56. When we combine base 1 and base 2, they equal 56. And our height is still going to be the same, so we're going to multiply it by 16. And when we do that, 56 times 16 is 896 feet squared. That just means that this area right in here, this part, all this part in here is the area, and that area equals 896 feet squared. Okay, let's go ahead on to the next one and learn about a rhombus. So let's watch the instructional video and we will learn how to find the area of a rhombus. Okay, in this video we're going to try to understand the area of a rhombus. So I've sort of already drawn it out for you using the same numbers that you see on your screen. So we have a rhombus. That's what this is here. And we have the first diagonal is 16 centimeters. And then the dotted line is the second diagonal, and it is 9 centimeters. So what I want you to see is that we can actually see that, and I'm going to get a different color. We'll do green. So you can kind of see that each one of these things form a triangle. Okay? So there are 4 tiny triangles to use when we're dealing with this rhombus. So I actually made a copy of this, and I cut it apart. So here's the first one. So this would be like this part of the figure here, where you have your first diagonal. So if you see that, that makes the base of a rectangle. And then I took this other part here and I cut it in two, and I made it fit on each side of the base. I made it fit on each side of the base. Just like that. So this forms a rectangle, and I'll try to draw an outline so you can kind of see the outline of it right here. There you go. Now you can see that when we break this apart, or we decompose this rhombus, we composed it into a rectangle. Now, the reason that happens is because the base of the rectangle is the same length as one of the diagonals, as this diagonal of the rhombus. The height of the rectangle, the height is half the length of the other one, because this is half. So the height represents half of the other diagonal. And that's how come we can use the same understanding about the formula, that we have a diagonal 1 times a diagonal 2, and we have half of that. So the formula, we can say half times diagonal 1, which is 16, diagonal 2, which is 9, and half of 16 is 8, and 8 times 9 is 72. And that gives us the area of the rhombus, which is everything inside the shape, as 72 centimeters squared. Okay, so let's move on to the activity 1, and this is the your turn. You have 4 problems to practice on your own, but go back and use the other 3 instructional videos to help you should you need it. You can pause your video, you can do it on another time, it's up to you. So let's go ahead on to the next section. So we have activity 2, and it is about the area of a triangle. And we're going to watch some more instructional videos, so let's go ahead and start. Okay, we're going to learn about the area of triangles now. And I've drawn a triangle here with a blue dotted line and a blue outline. And this is called a right triangle because we see that we have these little boxes. These little things here represent a right angle, which is a 90-degree angle. So that's why we call it a right angle or a right triangle. To figure out how much the area of a right triangle is, we can compare that to a regular rectangle. And we see that this triangle is half the size of a rectangle. So we know the rectangle has an area of base times height. So then we just need half of that, and we have what our right triangle area would be. So we have half times 7 is the base, 3 is the height, and 7 times 3 is 21. Half of 21 is 10 and a half. And you can also call it 10 and 5/10. Now, let's go on to one that's not a right triangle. Okay, so this has no right angles in it. We also see that this is the triangle here, and I'll try to do it in another color so you can kind of see it. So this is the triangle right here. Okay, the base is 10, and the height is 5. And we know we can use the formula of a rectangle, which is base times height, but then we're only filling up half of this shape with the triangle we want to know the area for. So we have the area is going to be half of 10 times 5. So what is 10 times 5 is 50, and half of 50 is 25. So the area of this triangle is going to be 25. Okay, so now we're going to go on to the your turn. And you have several different kinds of triangles, but you could use both of the instructional videos to help you solve these problems on your own. All right, activity 3. This one is about solving area equations. So you're going to have some parts of information that are going to be missing. So you can use the formulas, but you'll use some substitution in order to solve them. So here's the situation. We have a ship's triangular signal flag has a base of 8 inches and an area of 64 square inches. What is the height of the signal flag? So we can see that we have some information missing. So let's watch our instructional video. All right, so this is about solving area equations. So this is where we may have some information known, but not everything. So this problem that you see on your screen is about a ship with a triangular sail. So it's a flag. And the flag has a base of 8 inches. That's the base right here. We know it's the base because it's connected to the height. And that little 90-degree angle there is showing us that this is the height. And an area of 64 inches. That means that everything inside here has to make 64 inches squared. So it wants to know, what is the height? Well, the formula for a triangle is half times the base times the height, and it gives us the area. So let's just go ahead and start substituting for the information that we do know. We know that the base is 8 inches, so we put 8 in for the base. We know that the area, total area, is 64. So we substitute 64 for our area. Then we have half times the 8 times the height equals 64. So right here, half times 8, or half of 8, is 4. So we have 4 times h. We also can write that as 4h. Okay, we don't have to put that dot there, but we can make it 4h equals 64. Now we want to get this variable by itself, so we're going to divide it by 4. I'm going to divide it by 4, and whatever you did over here to get this h by itself, you have to do it to the other side so that we can keep our equation balanced. So when you divide 64 by 4, you get 16, and h is going to equal 16. So the height of this triangle is 16. Okay, don't forget, as we move to the your turn, that there is something missing in every one of these problems. So you're either going to be looking for the height, you're going to be looking for the base, the length, you may be looking for the area, but there's a part of it that's going to be missing. So try to identify what is it that it's asking you to solve for, and then just use your substitution for the information you already know. All right, moving to activity 4. This is the last activity. You're doing great. Let's go ahead and watch an instructional video on how we can decompose these shapes to find the area. These shapes are irregular shapes, so let's see what happens with them. All right, this video is about area of polygons, and for time's sake, I've gone ahead and drawn this out for you so you can kind of see. I have this shape here, and I've labeled each of the sides of the shape. So from here to here, it's 8 centimeters. from here to here, it's 4 centimeters. Same down here, 4 centimeters. But look on the side here. This from here to right here is 3 centimeters long. And if we go past the little hallway that goes out here, if this is your school building, you may have a hallway that goes that way. So if I pass the hallway, I have a straight line that goes from here to here, and that is 3 centimeters. Then I have this hallway, and that hallway is 6 centimeters long. So I wanted you to see that that's how we can identify different things going on in this figure. So what I did was I cut this, or I decomposed this figure into 2 figures. So now I have this large rectangle, I have this small rectangle. So let's talk about how we can find the area of this total figure. I now have 2 rectangles, so I know that the area of a rectangle equals the base times the height. So all I have to do really is put in the information for this section, and I know the base would be 4, my height would be 8, and then I know that 4 times 8 is 32. So that's the area of, let's just call this figure 1, okay? This we can call figure 2. And I'm going to do figure 2 in orange, just so we can kind of see the numbers that are a little bit different. Now, we still have a rectangle, so we're going to have area equals the base times the height. So what is our base going to be? We have 6. Our height, we're not sure. We've got this open hallway here, and then we have this end here. But we don't have a number. But we do have 2 numbers here that tell us from this point to this point, from this point to this point. This is 3. This is 3 more. So these little parts here total 6. And if we look at this far side, it says that this line from here to here cannot be any longer than 8 centimeters. So if we're looking for this little missing part in here, what we would need to do is subtract 8 minus the 6 we already knew. We knew there was a 3. We knew there was a 3. When we added those together, we get 6. So we can subtract them from the total, and then that should tell us what our missing number is. So 8 minus 6 is 2 centimeters. So our height is going to be 2 centimeters. And we say 6 times 2 is 12. So the area of figure 2, which is here, is going to be 12. I'm going to circle that, put it inside there, and I'll put this inside here so you can see it. So the area of this part is 32, and the area of this part is 12, and when we add both of those together, 32 plus 12, and that is going to equal 44. So the total area of this shape equals 44 centimeters squared, because we're talking about area. Okay, so let's go ahead to the your turn. There's your activity of 4 problems. I want you to remember that you can always go back and watch that video on how to decompose shapes. And there's 4 problems there, and they're using all shapes that you know how to use. And lastly, I just want to thank you for joining me today. And if you should have any questions about this lesson, please email me. I would be more than happy to return your email. I hope you stay safe. I hope you stay healthy. And I know all of your teachers miss you.